Hey guys, this is Shivam from EECS 1021. Hope you guys are doing well. As promised, this is the video solution for the midterm that we did last Thursday. So let's get right into it. Question 1, right out of the notes. 5 marks. Why is Java known as a platform-independent programming language? And how does the compilation process differ from C and C++? So let's go into the notes. Basically, if we start with this slide, the heart of Java is the JVM. Okay, so it's a virtual machine that sits on top of the regular operating system, and it converts your source code into bytecode, and that's run on the virtual machine itself. So your source code does not directly get compiled to the architecture of your processor. So if you have a 32-bit or 64-bit machine, that gets abstracted away by the JVM. The JVM takes care of everything. So as long as you have the JVM on any machine, and because it's so highly standardized, you do not need to recompile your code because of different platforms and different processors. So that's why Java is platform independent. And that's why C and C++ is not, because the machine code is executed directly by your target hardware. So that's why the compiler needs to know what the target architecture is. Is it 32-bit? Is it 64-bit? What's going on? And that's why when you move from platform to platform, that code is machine dependent because it requires a recompile. Okay, so that's the whole reason why Java is platform independent. So if we look at the marking scheme, a mark for mentioning that C and C++ have to be recompiled, a mark for JVM running into converting your source code into bytecode, a mark for mentioning that the JVM is highly standardized, and 2 marks for explaining the process. Source code to bytecode to machine code, and how the JVM's role works in that. And there was a nice little flowchart here. If you included, you got full marks for that. Okay, so that was question number 1, 5 marks. Question number 2, write the class for a phone object. Again, straight from the notes, but let's get into how I think I would attack this problem. All of a sudden, what I see is a big block of text. Attributes, constructor, getters, and setters. So what I would do is, as I go through this, I would get my pen and paper out and start writing down point form notes in the form of a to-do list, so I don't forget any of the information that I'm reading as I interpret this question. So I don't have a pen and paper in front of me right now. Obviously, I'm on the computer, so I'll simulate it using any notepad. Again, on your lab test, feel free to write down your thoughts, or in your source code as comments, or even in this TXT console editor called Notepad. Okay, so write the class for a phone object. 2 attributes, 1 constructor, the getter and setter. And it seems like set CPU speed has a bit of complexity in it. So there's going to be 4 methods, where set CPU speed is probably going to be the one that I do last. And a proper UML diagram. Okay, well, because I've studied hard for this test, I know that the UML diagram is the blueprint for my class. So that's the very first thing I'm going to do. So to do UML diagram. And I know that the UML diagram has name of class, attributes, methods, constructor. And as a note, I'm going to say, don't forget the symbols, private and public, minus and plus. Okay, so this solution guide is mainly for the coding, so I'm not going to get into actually drawing this diagram, but there are examples in the course notes that will help you do that. But once I have this, I can lay out the rest of my problem. So I know that this class is going to have 2 attributes. Attributes. And model name seems like a string because I'm combining. First of all, it tells you a name, and a name is usually a string, but I'm combining numbers and letters together. That usually looks like a string to me. So I'm going to go with string model name. And CPU speed is a decimal number, so I'll go double CPU speed. and that takes care of this section over here. Now in my constructor, it says, well, the constructor should have the ability to set the attributes of the class directly. Okay, and when I say set the attributes, that's setting off warning signals in my mind saying that this constructor should probably have parameters. So I'm going to say constructor with parameters, and the parameters are obviously going to be the attributes. So model name and CPU speed. Okay, and I'm good there. Getters and setters for each attribute. So I know there's going to be the model name, get model name, set model name, get CPU speed. Okay, you'll notice that I haven't put parameters or return types here. It's because I'm going to do that in the code anyways, and I might not have that much time in a real pressure situation. This to-do list is just a simple list to make sure that I know exactly where I'm going with this. Now, set CPU speed has some text, it has some complexity, so let's read it. There is a special consideration for setting the CPU speed. The CPU speed can only be applied by percentage, only be changed by percentage. So, the regular setter would just take in a CPU speed as it is and set our attribute to that. But that's not what we're doing here. We're only changing it by a percentage. So the example says, changing the CPU speed of a 2.0 GHz CPU by 10% will result in a CPU speed of 2.2 GHz. So now I see a little bit of what's going on. Okay, so basically they want to take in a percentage, do the math to apply that percentage to your existing CPU speed, and that's what's going to be changed. Okay? Now, this method should also return if the operation was successful or not. And the criteria for that is that the applied percentage change should be between 2.0 and 4.0 GHz. So what that means to me is I should do the math to get the temporary CPU speed change. And if that change at the end of the day is between 2 and 4, we're good. And we're returning true. And if it's not, then it's false. Okay? So let's put that into our to-do list as a set of instructions that we can understand instead of reading this block of text a million times. So set CPU speed, take argument as percentage, do math to find out new CPU speed. So I'm going to say previous CPU speed times percentage plus previous CPU speed. And that makes sense, right? Because if I have 2 GHz and I have an increase of 10%, 2 times 10% is going to be 0.2, plus 2 is 2.2. And that works out to the same math that was provided in this example. Okay? So if new CPU speed is between 2 and 4, again inclusive, return true, else false. Okay? So now, instead of reading this again and again, I can just go through my to-do list and start knocking things down. This makes a lot more sense to me. It's kind of like pseudocode as well, so I can go ahead and just start implementing this. So what I'm going to do is I've already opened a package in Eclipse, a project. I'm going to add a new class for phone. Public class phone. My UML diagram's good, so I'm feeling good about myself. Attributes, okay. Let's get right in there. String, model name. Of course, I'll make this private, since we want to make our code as secure as possible. Private double CPU speed, just like we said we would in our to-do list. Okay, now on the midterm I would just strike this out. Instead I'll just put it down and scroll up. So now the constructor with parameters, I know how to do that. Public phone, and remember I'm accepting parameters. And the parameters are going to be nothing else but my attributes. So I know that model name is a string and CPU speed is a double. And all I'm going to do now is set the attributes that are incoming. So when somebody uses this code to create a new phone, they will have to provide an existing model name and CPU speed so we can initialize this object to whatever they're telling us in the parameters. So this dot model name is equal to model name. Let's wait till Eclipse catches up. This dot CPU speed is equal to CPU speed. Okay, and now we've knocked down 3 of the 5 requirements. This is good. Again, I'm going to do the simple methods first because I know how to do them. Let's do the getters and setters for the model name. So the getter will be public, and because we're returning something, string get model name. We're not going to take any arguments. We're just going to return whatever the current model name is. Okay, and we need to return this dot model name. Okay, and the opposite is the setter, which means we're not going to return anything. So the opposite of returning something is not returning anything, which is void set model name. In this case, we didn't take any parameters. In this case, we will take a parameter. String model name. And we're going to say this dot model name is equal to model name. Okay, so now our getter and setter is pretty good for the model name. We know that we need to do the same thing for the get CPU speed. So again, public double get CPU speed, return this dot CPU speed. Okay, you'll notice that this never changes. Getters and setters, they're going to be the exact same. So you have to use them, practice them, and then keep using them in your applications. Their style never changes. So let's go back to our to-do list. We've completed almost 80% of the problem. So now let's set CPU speed. We know we need to take an argument as a percentage, and we know we need to return something. So let's get that requirement done right out of the way. Public, and we're returning Boolean, true or false. Public Boolean, set CPU speed. In this case, we're taking in an argument, which is going to be double percentage. Okay? So that's out of the way. We're good there. Okay, you'll notice there's an error. On your midterm, I mean, it's paper, so like you don't have Eclipse to tell you, but in this case, all it's saying is that, well, you specified you're returning Boolean, but I don't see that you're returning anything. So I'm just going to put return false here, just to get that compilation error out of the way. I don't like seeing red when I code. Okay, so we're taking in the argument as a percentage, and we know that we need to do the math to find out the new CPU speed, right? So that's exactly what we're going to do. So divide percentage by 100. So double P is equal, we'll give that a better, variable name. Double percent is equal to percentage divided by 100. Okay, and then we'll declare a temporary new CPU speed. So double temp speed is equal to, well, the current CPU speed, which is represented by this.cpu speed, times the percentage that we just calculated, plus this.cpu speed. You'll notice I'm not trying to use Eclipse's auto-populate too much because I want to simulate what happened on your midterm. So this gives me the new temporary speed that should be applied if and only if the new CPU speed is between 2 and 4 inclusive. So we need an if statement to do that, right? So we're going to say if the temp speed is greater than or equal to 2.0 and the temp speed is less than and equal to 4.0, we return true. Else, return false. And we can get rid of this. Okay? So now all our code is done. So on the midterm, you wouldn't be able to test it using Eclipse. I definitely suggest you do that in the lab test. So what you would do is open up a new class and go phone test. And then you would go public static void main string args. And then you'd create a phone. Phone p1 is equal to new phone. Obviously you need parameters. So we'll say, okay, well, S6 and CPU speed of 2.5. And then you would use P1 to test. So you can go P1 dot get CPU speed and print this out. Oops. There we go. Oops. Some issues. There we go. P1 that gets CPU speed. And if I run this, I get an error. There we go. I'm not sure what happened there, but 2.5 is correct because that's what I initialized it to. So then we know our code is working. Now switching back to midterm mode, you wouldn't have this facility. So you would have to do this individually. You would have to go through your code. So let's do that now. We're going to assume that our CPU speed is 2 to start. Okay, and the percentage is 10. So now we have to go through our code. So what's going to be stored in percentage? It's going to be 10 divided by 100. So that's going to be 0.1. Okay, and our temp speed is going to be calculated by taking our current CPU speed, which you said was 2. So 2 times 0.1 is 0.2, right? And then we add that to CPU speed, which was 2. So our temp speed is 2.2. How do we know that's correct? Well, it's right in the example. Increasing by 10% is going to result in a CPU speed that's 2.2 gigahertz. Okay? So we know that this math is working correctly. If the temp speed is greater than or equal to 2 and the temp speed is less than or equal to 4, then we return true. Well, is 2.2 greater than or equal to 2.0? Yes. And is the 2.0 less than or equal to 4? We're good. Okay, so then this code works. You can tell that this code works. You could also do the same thing with negative 10, in which case this would be 1.8 and this particular code would return false. Okay, because 1.8 is not greater than 2.0, so it's not supposed to. Okay, so you'll notice that we said inclusive, so it's greater than or equal. Some of you forgot that on the midterm, and this question is iced. We're all done. So we can wipe out our to-do lists, and we're good with this question. On to the third question, the dreaded triple-double question. Okay, so consider the following array of numbers for 15 marks. Again, we know what a triple-double is, points, assists, and rebounds. If all of them are greater than or equal to 10, then this particular player got a triple-double. Okay, some of you tried to take a shortcut with the math, which is always encouraged. That's what mathematics are for, but you should make sure that shortcut actually works. So some of you said, okay, well, what if I sum the points and assists and rebounds together? Since each individual one has to be greater than 10, it follows that if the sum of these are 30, then you get a triple-double. It sounds good initially, but when you work through it a little bit, you'll realize that that's not correct. If somebody's having a great night and they're not interested in playing any defense or passing the ball, they might rack up 40 points but have 0 assists and 0 rebounds. They did not achieve a triple-double, right? Because you have to have greater than or equal to 10 in every single category. So that particular mathematical shortcut does not work for getting a triple-double. Got to play defense. Got to pass the ball. Anyways, let's get into how we would do this question. So the first paragraph is dedicated to knowing what a triple-double is, so we understand that. Okay? Write a method which accepts a 2D array of integers and returns the IDs of the players that achieved a triple-double. So I'll read that a couple of times. I write a method that accepts a 2D array of integers. Okay, that makes sense to me. I'm accepting a 2D array of int. No problem. I'm going to return the IDs of the players that achieved a triple-double. So in my mind, I know I need to return 1 and 3. How I do that is up to me. I can't just print it out. I can't say that, okay, well, player ID and player 3 did that. This needs to be a method that returns a valid piece of data. Okay, I can't just use system.out.println. Then in bold, I have to justify the choice of the return type. Is it going to be a collection or an object? Why is the return type that I chose the best for this requirement? So that's the big deal with this question. Okay, so let me take my information one piece at a time. So again, to do write method that accepts 2D int, and it's going to be int list. That's for example. Okay, and I need to return all player IDs. And just for emphasis, I'm going to say all, like that. Return type question mark. So I need to think about this before I start jumping into my code. What's going to be the best return type for this? Now I know I need to parse through this 2D array one row at a time. So I know I need to do that. I also know that I'll have to do some calculations inside my for loop to determine if I got the triple-double. But the question that's bothering me right now is this. How do I return this thing? Okay, now the first clue is that IDs, this is plural. So primitive data types aren't going to work. I'm not going to return an integer, I'm not going to return a double. Okay, I'm probably not going to return a string because that's not really a valid piece of data. That's just one string. I can't get anything from that. It's work for the person who's going to use this method to take that string and convert that into numbers. Because you're probably going to use commas to separate the player IDs. It would be 1, 3 in this case. So I'm pretty sure I'm going to need a collection or an object or some type of array. So initially, because it's a collection of integers, I'm going to lean towards array, right? But then I know that arrays are static. Now, before parsing this array, before going through this array, I don't know how many players are going to achieve triple doubles. So that rules out the array, okay? Because I might allocate 3 spots or 3 spaces of memory for my array, but only 2 people got triple doubles. So that 3rd spot's going to be wasted. It's going to be null, and that's going to cause a lot of problems for me in the future. So I need something that can dynamically keep adding, and I know that's an array list. Okay, so the array list works just the same as the array, except that it's dynamic. It can add and remove things at will. So this question mark now, I know, is going to be an array list, and that suits my purposes. So now I've got the skeleton of my code. I know I'm going to accept a 2D array of integers, and I'm going to return an array list. Now, how do I do this question? Okay, well, I know I need to go through each and every single row. So I definitely need one for loop for going through each row. And basically what that means is I want to go through each player. So each player has a row. And by looping through each row, I'll have access to their data for that night. The points, assists, and rebounds, and their player ID. Okay? Now the temptation here is, because we did some examples in class, to go through the 2D array is to put another loop. So in that case, I would go through the first row first, and then I would loop individually through the ID, points, assists, and rebounds. And you can do that. But in this case, I don't think I need to, because once I'm here, I have access to all these guys individually. I don't need to access them together. I have access to them. So if I go player ID at I, which is the row, at 1, I have access to the points. If it's I at 2, I have access to the assists and the rebounds. So really a double for loop is not necessary. So once I'm in this loop, all I can do is get player ID, points, assists, and rebounds. If points, assists, rebounds, all greater than or equal to 10, I'm going to add the player ID to my array list. Else, do nothing. Okay, does that make sense? One for loop for going through each row. I'm going to go through every single row, and then I'm going to grab their points, assists, and rebounds. I'm going to make sure they're all equal to 10, and if they are, I'll add that player ID to my array list. So the trick to doing these questions is imagine how you would do it without any code and by yourself. So if somebody gave you this data and asked you to tell them who got triple doubles that night, you would do this in pretty much the exact same way. You would go through each row, and then you would make your calculations, and then put one in a separate list. You'd write that down somewhere. And at the end of the day, you would come back and say, well, players 1 and 3 achieved triple doubles. Right? So now we've got our to-do list. We have a general idea on what we're doing. Let's go into the code and bang it out. So new class, triple double. And I'm going to write my method now. So I know I need to return an array list. Public array list. And my array list is going to be of integers. Integer. Let's name my method. Find success IDs. And as input, I'm going to take in a 2D array of data. Okay, and again, we've got the same type of errors, so I'm going to say return null for now, and I'm going to import the array list. Of course, on the midterm, you didn't need to do any imports. I was totally fine if you just went straight in with this. Okay. Also, in your midterm, you didn't need to include the class. I just wanted the method. Okay. Let's begin. First thing we should do is probably initialize our return object. So we're going to say array list integer success list is equal to new array list integer. I think there's a spelling mistake there. List integer. That's good. And now instead of returning null, I'm just going to return success list so I don't forget. Okay, and my code is looking nice. There's no red marks. Now I want to begin looping through the array. So what I'm going to say is this. For int I is equal to 0, I is less than data.length, I plus plus. And I'm going to put a little comment here. This loop will go through each row one by one, and in brackets, each player's data. Okay, so now we're good. We'll put that up. Focus on what we need to do here. One loop for going through each row. Again, we're done that, so we'll strike that out. Now we need to get the player ID, points, assists, and rebounds. So to make this really easy for us, I'm just going to declare them right in the loop. So int ID is equal to data at I at 0. And that should make sense to us. So what I'm saying in this is that, hey, go into where you are right now at the loop. So the first time it's going to be 0. So the data at the 0th row, and always go to the 0th column. So the loop is going to go the 0th row, and the 0th column is going to be 1. And then the next time, the I counter is going to increment to 1. So it's going to be 1 at 0, which will return 2, and then 2 at 0, which will return 3. That's all I'm doing here. So each time I go through the loop, I'm getting a new player ID. I'm going to do the same thing here. Int points is equal to data. Again, on your lab test, you feel free to copy and paste, but since I'm simulating the midterm, I'm not going to do that. Int assists. Actually, what was next? Yeah, assist was next. Okay. So data at I at 2. Int rebounds is data I at 3. Okay. Now, if I'm in a lab test mode, what I would do right away is do this. System.out.println ID. And then I would do similar what I did over here and go ahead and run this method just to make sure that I'm getting the data that I need. Okay, for example, if I made a mistake here, this would print out only player IDs 2 and 3. So then I can go back to my code and make sure it works. So always write little bits of code first and then test them to see what's going on. Okay, I go back to my to-do list and I got all this data that I need. So now I have all the data that I need to make sure that this particular player can be assessed if they got a triple-double or not. So all I'm going to say is my if statement. If points are greater than or equal to 10, and assists are greater than or equal to 10, and rebounds are greater than or equal to 10, then I'm going to add this particular player ID to my array list. Triple-double is achieved. So what I'll say is success list, because that is the array list that we initialized, dot add the ID that we declared up here. Okay? We don't even need to put an else because there's nothing that we need to do in this case. It's just it's pretty much done at this point. Okay? Else do nothing. And that's it. That's the simple solution to this problem. If you added another for loop here, then you would have to keep track of a counter in between. It would just make your solution a lot more complex. So this was a pretty simple question. So that would have got you 10 marks. If you did that, you would have got 10 out of 15. Now, what I was hoping for, or some of you got stuck, is that you would still take time to read this and say, justify the choice of the return type. Why is the return type that you chose the best choice for this requirement? Well, knowing that you have 5 marks for justification, you wouldn't have known that, but since this is in bold, I would have assumed that, you would have taken a stab at this. But all I wanted to know is, what made you choose this as your return type? Why not an array? Why not a hash map? Why not an object? I think that array list is the best way to do this, but maybe you could use a hash map to do it. Maybe you can use an object to do it. That's totally up to you. You just needed to justify why. And in this case, the only reason we're doing this is that we can do this. SuccessList.addID. With the array, we would have to keep track of where we are in the array to add it at the next index, right? And since it's static, what happens if the amount of players that achieved a triple-double are less than the list? Then we would have a big gaping hole at 3. And that's not good for anybody. It's a wastage of space, and it'll provide lots of problems in the future. So an array list is a dynamic implementation of array, and that's where we're using it, because we don't know how many players achieve triple-doubles, and that's the whole reason why we're using array lists, because they can scale up and down dynamically. So this is a solution to that problem. If you didn't know what you're doing and you wrote some notes, this is how I would do it, and you had some semblance of the code, you definitely got 4 to 5 marks. So that's the solution for question number 3. Going right into question number 4, which is the last question on the midterm. This is pretty straightforward. Demonstrate your knowledge of composition by implementing 2 classes, employee and salary. So we're talking about composition and aggregation. Okay? So we know that employees and salaries are linked because an employee has a salary. Okay? So you needed to implement 2 different classes. Employee and salary. Okay? Notice that this is not a primitive data type. This is an actual object. Okay? This object is composed of wage and currency. Okay? So that was the whole point of aggregation, because we could have just put wage and currency into employee, but that doesn't really make sense. Right? An employee doesn't have a currency. That doesn't make sense as an attribute. It's not intuitive. But an employee has a salary, and that salary has a currency, right? So that should make more sense to you. Anyways, the rules of aggregation generally are that when you're implementing this stuff, we want to implement the aggregated part first. So salary should be implemented first because we don't have an employee without a salary, right? So we're going to go into the code and implement salary first. First, though, we're going to do our to-do. So, with our to-do, we know that this question is aggregation / composition, right? And we know that employee has a salary. Both are classes. Implement salary first. So again, salary class has two attributes, wage and currency. So wage, okay, we pretty much know that's a double, right? Double wage. And then currency, well, CAD USD, that seems like a string to me. So string currency. Just to make this a little bit more clear, I'm going to say attributes. Okay. The methods are setters and getters. So set wage, get currency, get currency. Okay, those are the methods. When initialize, the default salary to start with is 1,000 Canadian dollars. Okay, so again, initialize, that should trigger off alarm bells in your mind. Initialization almost always deals with, in objects, the constructor, because we use the constructor to initialize a new object. So my constructor, no arguments, it's not needed because we are setting the default salary to 1,000 and the currency to CAD. Okay, so that's pretty straightforward. So let's code that and get that right out of the way. New class, salary. So I refer to my to-do list, attributes, private double wage, private string currency, so that's done. Methods, set, and get for these setters and the getters. Okay, no problem. So public void set wage, accepting a parameter, double wage, this dot set wage is equal to wage. Sorry, this dot wage, obviously. This dot wage is equal to wage. Public double get wage, return this dot wage. Okay, because we're not accepting anything, we're just returning what the wage is. Same thing with our currency. Public void set currency. We're taking in the parameter as currency. So what we'll say is this dot currency is equal to currency. And then the same thing that we did for the get wage, we'll do here. So public string get currency, no arguments, return this dot currency. So let's see if we're done. We're not. We still have to do a constructor with no arguments. Public salary, no arguments, and we know we're setting the wage to 1,000 Canadian dollars. This dot currency is equal to C80. And this class is in the books. So we're good. Now we're going to go to the composed part of this, or the aggregated part, which is employee class, right? And it's pretty much got the same style of what they want. They want name, ID, and salary should be obvious because an employee has a salary. So let's put that in right away. Employee class. attributes are string name, int ID, salary, sal. Okay? Methods, getters and setters for the name, an ID, a getter for the salary, increment salary, and toString. Okay, so I haven't seen these before, but I'm not going to worry about them right now. Let me just focus one at a time and see what's going on here. So, methods, get name, set name, get ID, set ID, get salary. Now there's a trick here. You can implement a set salary method by yourself, or you can use the set wage and set currency methods of the salary class themselves. That's totally up to you. It depends on your implementation. Okay? Because we are getting the salary, right? But setting the salary doesn't mean that we're saying 1000 CAD. We have to set the wage and currency individually. So that's up to you. So for now, I'm going to leave it like that. And put set salary. Okay? So, we also need to do increment salary in toString. But I'm going to leave those for now and focus on these methods. So get name, get ID, set name, and set ID are very straightforward. So I'm going to do all that as quick as I can. Because it's pretty routine by now. You guys should know exactly how to set and get parameters. Employee. So we know that name, ID, and salary, private string name, private integer ID, and private salary cell. Now, one thing I left as a trick for you guys here is that I didn't explicitly tell you to create a constructor, right? But that's the whole point of composition and aggregation, right? You need to instantiate the employee class in order to achieve a valid salary, right? So that should have been apparent to you. So in my to-do list, I'm definitely going to put constructor, because without a valid constructor, you're not going to be able to access any of the other methods, because the salary won't be set. So we're going to go public employee, and we need parameters. String name, int ID, salary cell, and then the regular stuff. This dot name is equal to name. This dot ID is equal to ID. This dot sal is equal to sal. So now our constructor's out of the way. Now our attributes out of the way. Now we're going to attack the easy methods. Public void set name, string name. This dot name is equal to a name. Public string get name. Okay, so repeat the dosage for ID. And the getter for this. Public int get ID. Return this dot ID. Okay. Even getting salary is pretty easy. Public salary, get salary. Yeah, return this dot sal. Okay. Now, for setting salary, you have two options. You can do it the standard way and say public void set salary, and you pass in a salary object. Right? And you can say, okay, well, this dot sal is equal to sal. So that's totally valid too, right? The other thing you can do is do this directly. So I'm just going to copy and paste this, or just write it again. Public void set salary, and instead of passing in a salary, you could just pass in the wage and the currency. And then I would say, okay, well, this dot sal dot set currency is currency, right? And this dot sal dot set wage is wage. Okay, and that's going to set the salary for you directly. Okay, so the difference between this implementation and this implementation is that you'll have to pass in the salary object first, and then you can set the salary. So you have to do this work outside. And in this one, all you have to do is pass in the wage and currency, and this will set that for you directly inside. So I prefer this implementation, although I'm going to leave both of them in here, and that's totally valid. This is called overloading, and you'll learn that when we do inheritance part 2, we can have the same method name, but the arguments are different. Therefore, this is overloading and not overriding when the method name and the arguments are exactly the same. We typically override when we're inheriting classes, but obviously there's no inheritance in this question. So we're good with our methods, and we think we have everything set up so that we can attack the other two questions. So increment salary increments the current salary of the employee by 10%. Okay, so that makes sense to me. So what I need to do in increment salary is get the current salary in terms of its wage. Because remember, a salary is composed of two different things, a currency and a wage. Multiply wage by 1.1, and then here's where most of you missed it. You still need to set that salary back. Set the new salary. Because just by multiplying the wage by 1.1 and leaving it at that doesn't update the employee's salary. You still need to set that new salary for the employee to reflect those changes. Okay? So if I go public void increment salary, I don't even need any parameters because I'm getting incremented by 10% each time. So what I'll say is double wage is equal to this dot sal dot get wage, and that's going to give me for this employee their current salary's current wage. Okay, it'll store that in this variable, and then all I'm going to say is, well, wage is equal to wage times 1.1. So if I have a salary of $1,000 and I'm running this method, I should get incremented to $1,100 because 10% of 1,000 is 100. And then all I need to do is this. I need to set that salary. So what I'm going to do is this dot sal dot set wage is this wage. That's all we have to do. Okay? In this case, we had to go inside the employee's salary, get the wage, modify the wage, and then set it back. So these 3 lines of code correspond directly to these 3 lines of notes. So you can see by putting your thoughts onto paper, your code becomes a lot easier. Okay? Now we go to the toString method. Should return a string that consists of the employee name, ID, and their actual salary below. Okay? So this is just an example. Some of you hard-coded Michael and 10 and 1,000. You didn't need to do that. Instead, you have to get their current name, ID, and salary. So this is actually pretty straightforward. Let's go ahead and implement it. Public string, toString. We don't need any arguments because all the data is inside our class. So I'm going to say string strrep as in a string representation. I'm going to say strrep is equal to, okay, well, what's employee name? Employee name, and it wants colon after each particular character. So employee name space plus this dot name plus ID plus this dot ID. Let's go back and refer to what they want. Salary. And then what you'll say is this dot salary dot get wage plus this dot sal dot get currency. And you end it. Then we just return this string. Okay, just for the sake of perfection, I think I'm missing some commas, although if you didn't do that in the midterm, you still got full marks. That's not a big deal. Employee name Michael, so there's a comma. After this, each and every single one, there's going to be a comma, like that. And I spelled employee wrong. And that's how you do it. So that completes the midterm. Let's go through the marking scheme for this question. I tried to be as generous as I could. 1 marks if you got the attribute of the salary class right, 2 marks for all the setters and getters, and 2 marks for your constructor. And for the employee, 2 marks for the attribute. I definitely wanted you to have this constructed inside. So that was a big deal for me because it demonstrates aggregation. 3 marks for all the getters and setters. 3 marks for the proper constructor. 3 marks for the increment method. And again, I was really looking for doing this. Most of you got this far and then left it at that. But what was important is that you set it back. 4 marks for the toString method. Retrieving, concatenation, and returning. Honestly, this should have been 1 mark because you've been doing it since the first day, but I just thought I'd give you some bonus in case the triple-double question messed you up. So that's the end of the midterm. The takeaway I want you guys to take from this midterm and the video is how this to-do list makes your life a lot easier. Okay? I do this every day when I write code. It makes my life so much easier. It's easier for troubleshooting, debugging, for everything. Absolutely everything. And the second thing is that I want you to test. So in your lab test that's coming up, as soon as you've written a bit of code for your salary class, go ahead and test it. Then test the employee class. So little bits of testing will really go a long way in making sure that your application is running properly. So all the best, and I'm sure you guys are going to kill the midterm on Wednesday. See you then.